Yes, Austin.
9, sorry. Number 9. Yes.
Okay, the first question asked is about worksheet 9, number 9. All right, let me see if I can snap a picture and make this a little bit bigger so that I can write on it.
No, I just want good movie. Can you tell me Miss Johnson? I just know how his day was. You didn't answer though, this weekend. How was your weekend, Mrs. Hopper?
It was okay, thanks.
Good.
The Blackhawks lost. That was very depressing. Okay. The shadow of a tree lengthened 70 feet. Okay. As the angle of elevation of the sun decreased from 60 degrees. So he was looking up at the sun up here, 60 degrees at the end of the shadow, and then he walked out to the end of the shadow here, and it was 40 degrees. Okay, so the sun was going down lower, and it increased 70. We're supposed to find the height of the tree here. Any ideas?
Well, the blah, 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 blah.
We need to talk about
Angle
this
right
triangle.
there is 120 degrees.
What else?
Alright, then if that's 120, then the other one is 20. Then you do sine 20 over 70 is equal to sine 40 over the hypotenuse. And then
No.
since it's a 30, 60, 90, and you're trying to, what?
Get wrecked.
Over 70 feet.
There's no hypotenuse in this blue triangle.
No, I'm talking about you're finding the hypotenuse of the small triangle.
Okay,
Over sine 40 is equal to the hypotenuse of the small triangle.
there's no 40-degree angle in the small triangle.
There's one right there, right above to the top right of 70 feet.
In the big one, you're finding the one on the left side. What she's saying is you're finding the hypotenuse for the other triangle.
You're gonna find this side, is what you're saying?
No, the other one. The other
No,
one.
sine
Smaller
40
one.
over x.
There you go.
And
That
that
one.
x is the hypotenuse.
It's not, though.
I don't know what's happening. I'm just
No,
saying
I'm saying we're finding a hypotenuse of this triangle.
Okay,
And then that is
but
what
you're
we're
not
doing.
finding it with a 40-degree angle.
You're doing the sine 40 of over x, right?
Okay, but it's not, it's side x here, it's not a hypotenuse, is what you're saying.
Get wrecked. Get wrecked.
Okay. Sine of 40 is across from x. So Lizzie's saying we can find this side right here. Okay? Then once we have that side, you can find the height either using, again, law of sines, or using just SOHCAHTOA stuff, or like Lizzie said, it is a 30, 60, 90. You can use the rules for 30, 60, 90 if you remember that. But what you eventually want to find is this height. Did I answer your question, Austin?
Yep. Then you just do it on the bottom, right? It's sine 20 over 70 equals sine 40 over 6.
That, once you find x right here,
Yeah.
this will give you x, but then it wants the height. So you have to do something to find the height after that.
Okay, and you do that. Because then you'll have one side and one angle. And oh, that one's right, so you can find the other angle, and then you can do law of.
Yeah, or you could just do, it's a right triangle, so we can just do sine equals opposite over hypotenuse,
Oh, yeah.
if we wanted to. Yes,
When it says all law of sines, cosines,
that just means that's what all that is on, yeah.
I'm just making sure.
Wait, are we doing questions?
Yes.
Can we do number 31 on the book page 622? The law of cosines, please?
Well, of course we can.
31 right here.
Yeah.
Okay.
Yeah.
This is page 622, which is section 10.1. Question number 31. Let me get rid of this little guy. Okay. One diagonal of a parallelogram is 6 centimeters long. and the other is 13 centimeters long. They form a 42-degree angle with each other. How long are the sides of the parallelogram? And it says, hint, the diagonals bisect each other. Okay, so this diagonal is bisected, and this diagonal is bisected. Which one looks like it might have been 6 to you?
The
Maybe
smaller one.
that one looks shorter to me. So that would be 3 and 3, right? And this one looks like the longer one, so that would be 13 cut in half is 6.5 and 6.5. Does that seem okay?
Yes, it does.
All right. And they form a 42-degree angle. Well, that's either this angle or this angle. I'm going to go with it's the
smaller one.
acute-looking one here.
It's so cute.
This one would be 138. Did I do that right, guys?
I assume so. Yeah, you did.
Okay. Those make a linear pair. Now we just need to do law of cosines to find that side using the 3 and the 42 and the 6.5. And then we can use the 3 and the 138 and the 6.5 to find that side. We're supposed to find both sides, okay? Does that seem okay now that the picture is all drawn?
Yes, thank you.
Yes. Okay, there's a picture that's hard to see. It's at the top of the next column. Goes with it. I'll show you 1 second. I'll make sure everybody has this written down.
Oh, the 148? No, 138.
138 and 42, I think.
SAS here in district law of cosines, right?
Yes. All right. The question asked was number 23 on this same page, which is page 622, number 23, it's section 10.1. There is a picture, but it's hard to see. It's at the top of the next column. So if it, you know, the problem's at the bottom of one column and the picture's at the top of the next. So if you don't see it. But the gate is 8 feet long. And when it swings open to here, the gate is still 8 feet long, right?
Wait, what?
And the distance that it swung open right here or traveled was 10.8. And now we need to find this angle. So it's a law of cosines question backwards, finding the angle. Something like that. Does that seem okay?
What's the test on this or quiz?
Wednesday. Yes.
Do we get like a sheet with the formulas?
Yes, I have an updated unit circle sheet for you here. It doesn't have a zillion different, there's like one way that it's written out for law of cosines. It's not written out every possible way you could. So, I'm sure you know what it means. It's on the side, below the unit circle, it says law of sines, law of cosines. Is that okay? What else can I answer questions on?
Ooh, look at the one of those sheets with those kind of.
Sure, you should maybe be doing homework.
Number 15 on 10A.
Okay, back to the worksheets.
Yes, please. 15.
Oh,
On the worksheets, question number 15. This is a very tiny drawing that makes it very confusing. So let me see if I can make this bigger, and then we can go over this a little more clearly.
Science. Is that a beta?
So it is a beta.
Yeah.
Right, we have a airfoil or something that helps wind resistance here. They want the wind to go up and over the back of the trailer here. So this is 4 foot. This side right here is the top of the truck, and the angle made between the top of the truck and the airfoil is 18 degrees.
Okay.
We are trying to find this little brace over here. And the part that's confusing is what this 10 degrees is telling us. Well, the 10 degrees, the beta is 10 degrees. It's telling us that it's 10 degrees above the horizontal. So let me just, ugh. Yeah, that last line didn't work. I'm not quite sure what I touched there. I hope I didn't mess up the recording. This is 10 degrees in here, and this is 18 degrees. Oh my goodness. Let me try that again.
It's very ugly. Mine is too, though. It's all good.
But it's supposed to be vertical. Okay, let me try again.
Start from the bottom. No.
I can do a nice job if I just stand up here. Okay, this is 10 degrees, and this is 18 degrees, and this is 4 foot,
Oh, I
and
feel
this is
you.
X.
Oh, I feel you. You can do 8.
So if this is 10, and this is 90, this is 80.
Yeah.
Next to an 80 is 100.
Oh my gosh.
This is 18, and this is 100, maybe 62. How did I do?
You did great.
Okay. So then we have the sine of 100 is across from 4 feet in the same way the sine of 18 is across from X feet.
I feel dumb.
Yes. It's hard to tell on a picture.
I don't know if this is really a question, but I tried, I didn't even figure that out by me until you started doing it. But I did the sine of 28, and I got that x, which is, where is that? That would be, that'd be this, right? And then I just did it for portion. But I got 1.21, so it was kind of close.
It was close. Yeah, I don't know. See, I think what's going on is this 90 is close to 100. So this triangle is somewhat proportional to this triangle, but they're not exact. Because you have to have equal angles to be similar triangles.
So I did it. Very interesting. I think I know what it is.
So X is the length of the brace, right?
Yeah, that's all we need is X.
I'm trying to do this one, thing right here. It's number 17 on page 634.
Okay. Page 634.
I'm putting off signs, and I'm trying to find the second sign of the answer, the greater than 1, and it's not letting me.
Okay, if it's greater than 1, it doesn't work.
That's what I thought.
So you just write no triangle possible.
Oh,
Which number is that?
number 17.
On,
We're not supposed to do that one.
Here we are.
17, here we are.
Oh, wait, which?
I'm on the wrong page, I think.
634.
Oh, shoot, that's why.
Okay, this one?
Yeah, number 17.
So if you have a triangle where B is 47 degrees and across from that side B is 15, and you have some angle C is 25, that is an angle side-side situation, so it's definitely possible that it doesn't work,
Okay.
okay?
I did the log sign. but
So you set up 47 is across from 15 in the same way the sine of C is across from 25. And when you did that, it was greater than 1, so it wouldn't do second sine, right?
Right.
So then you just say no such triangle possible or whatever.
Sine of 181 is nothing.
Yes.
Can we do number 39 on page 634?
You just need to split this into 2 triangles, Rachel. And actually, since we know all the sides and all the angles, you can do the area of this triangle is 1/2 AB sine of the angle in between. And then you'll do something down here using 68.4, 135, and 72, and add the 2 areas together. Does that make sense?
Yeah.
It was easier than the one we did where we had to use law of cosines and then the Heron's formula and blah, blah, blah. This one, we have all the sides and all the angles, so it's not hard. And you should get the same answer if you chose to divide the quadrilateral the other direction or something. You should get the same answer. Yes? Yes.
Thank you.
Victor, are you writing these down?
Yes.
Zachary?
Did you do 14 on 10A?
Okay, this is number 14, back on the worksheets. And the problem is students want to assume that we're supposed to figure out how high this is, but you can't find that height straight off without finding something else first, because this does not split the 2.32 evenly, okay? So we need to treat it as a giant triangle. If we have a 28 and a 37, what does that make this guy up here? Is that wrong, guys?
Nope. That is,
That is correct.
Is it right? 125? Okay, so now we need to find one of those, okay? So,
it should be 150.
Aha!
It is 150.
yeah, I was,
did it on my paper.
I'm sorry. I'll leave.
okay, no, you're fine. I never trust myself subtracting. So we need to look at this giant triangle first and find one or the other of these sides. So if we find this side x, we would say the sine of 115 is across from 2.32, is it kilometers? Miles? Miles? In the same way that the sine of 37 is across from x miles. And then once we know that side, what'd you get?
I got 0.655 miles.
Right here?
Oh wait, no, that was the height, sorry. I
Oh,
got 1.396, I believe.
I'm still reading.
okay.
Oh,
So
let's
then-
say I'm wrong.
What?
What is it?
What mode am I in? The right mode?
What did you get? Give us that one.
Yeah, I think got 1.54 now.
Okay.
Yeah, it's less one.
And then we need to find this height, so we can use either law of sines again, using this 90, or this is just opposite over hypotenuse. You just use your right triangle trig. It works the same if you use law of sines again, though. Okay?
I don't even, how did I get that?
What else? Yes.
We did 20 on 10B. I gotta repeat those.
All right. I'm on number 20. A blimp is sighted simultaneously by two observers, so our blimp is up here, okay? What blimp should it be? Does ESPN have a blimp? We'll call it the ESPN blimp.
One with the yellow letters or blue?
Yeah. Okay, this is a 650-foot tall tower. Observer A is at the top and observer B is at the bottom. Observer A has an angle of elevation, so from the horizontal up, he's looking 32 degrees up. So what is this entire angle between the building and his line of sight up there?
Wait, what?
32 is from the horizontal up, so
190.
90 plus 32 would make this 122, okay? Now, observer B down here has to look up 56 degrees above the horizon.
Oh man, I did it wrong.
So this would be 90 minus 56, or
34?
seems right to me, 34. All right, then if we, what's the angle, little angle out here then? If we have a 122 and a 34,
24.
okay? There are two questions asked, one of which you can find now, and one of which you still need to do something else before you can find. The first is, how far is the blimp from observer A? Can you find X right now?
No.
Sine 26 over 650 equals sine 34 over x, right?
Yes,
I mean,
Oh.
that's right,
x
Michael.
lower, not 26.
Hey, you were right, Scott.
Now, the second thing it asks for, though, is how high the blimp is. Anybody have any, there's a couple different ways we could do that, but
We use like the 56 and 90, and then we find like one on the left side. Like sine of 34 over 893.6 equals sine of 122 over x. Can we find that?
yeah, if we found this side, I think this is what you're saying. Can I call that Y for a minute?
Yeah.
Yes. So you could do the sine of 122 is across from Y in the same way the sine of 24, that's supposed to be a 24, sorry, is across from 650. And then once you know Y, you can use this little right triangle to find the height. I think you could have also extended this 32, found this little distance, and then added it to the 650.
Did it just have you find the distance the blimp is from the observer for fun?
I guess so.
'Cause I was gonna say, I found the height first, and then I'm like, oh wait, I have to find the distance here. And then I
How did you find the height first? Oh, you just didn't, you found Y instead of X first or whatever. Yeah, yeah, yeah. Gotcha.
Yeah, I just like it.
Rachel?
Can we do number 5 on
Wait, so,
observing A?
wait. What do you define
Yes.
blimp for exactly?
Be-
find y and then
we're
you-
trying to find the height, and so we need to find another piece of information before we can find the height. So we found y to help us find the height.
So then we use, wait, so then we use y and
What?
In this little triangle out here,
That's smaller than 60.
once we know y, we can find the height. All right, Michael?
Oh, wait,
Maybe.
Yeah.
It is a good number.
No, because this is all multiplied together.
Oh, we can solve the whole.
Oh, you have, okay. No, you have to do this, minus 8 squared, and divided by that, remember? Yes. I think that looks right.
Gonna understand how I got this small number. I need this one.
Was it Rachel's worksheet? It was worksheet again, but number 5? Okay. This one?
Oh, dude, you're so right, Scott. You're so.
Okay, it says, Rachel, that it's an isosceles trapezoid, okay? This is on the worksheet, I think it's side 9A.
Wait, we're not supposed to do parallel. Wait, no. There we go.
The sides are 10, or the bases are 10 and 15, that means the two that are parallel. And one of the angles is 132. If it's isosceles, this is also 132 because it's got a line of symmetry down the middle. And what about these angles then? Anybody know how that goes? If these are parallel, what's the relationship between this angle and this one down here?
180.
They are
I
supplementary.
think.
Yes, they are supplementary. So does that make us 48 maybe? Okay. Now, to be able to find the area of a trapezoid, you could do a lot of ways. You could find the area of the triangles on the sides and add it to the rectangle that's in the middle if you didn't know the formula, okay? The way you probably learned was something like half the height times the sum of the bases. Or sometimes teachers teach it, you average the two bases and then multiply by the height, okay? Something like that. If I were to draw this in so that I get a rectangle down the middle, this becomes 10 right here, right? And because there's a line of symmetry, this leftover piece here and here totals 5. And mine doesn't look symmetric, but it should be 2.5 and 2.5. So now you can use a little right triangle trig here to find that height. Does that seem okay?
Seems great. Oh, this is terrible.
Can I help with something else on bookwork or worksheet? I remember.
Candace, how far can we
Yes.
go for 50 on page 636?
Oh, okay.
Okay, this is actually exactly like a question we just did. It says we have, this is page 634, number 50. This is assignment 10.2. Okay. Two observers, oh my goodness, that's really crooked, sorry, are 400 feet apart. There's a tree growing up in between them. One guy has to look up 51 degrees, and one guy has to look up 65 degrees, and we're gonna pretend the tree's making a right angle with the ground, which is not really straight ground, apparently. How tall is the tree? We have to first treat it as a giant triangle and find one of these sides, either X or Y over here, and then we'll be able to find the height. You don't have to find both, but you need one, X or Y, and then you'll be able to find the height, okay? When you treat it as a giant triangle, if you have a 51 and a 65, does that make it a 64 up there maybe?
Yep. Not
You did
64.
math wrong, Scott.
So then you need to find either X or Y, and then once you have those, that you can find H, okay? It asks you actually to find three things, pain in the neck. The height of the tree, and then you need to find these two distances down here, both. Well, once you know one of them, 400 minus 1 will give you the other one, but.
Okay.
Yes. Okay. Yeah, this is we will actually do a lot of these vector and aerial navigation problems next week. I am going to be kind and not do these equal questions until after the ACT, okay? But this one says a plane flies an angle of 105 degrees. It's clockwise off of north, okay? If you go to that exercise 34 on 10.1, it says clockwise off of north. So here's the north-south line. And if we were to go around, how much is it, 105? You know what, I made my picture kind of big here. That would be past 90, does that seem okay? Okay. And the plane goes for a while. So here's the plane, flying this way. And then he decides to turn, and his new path off of north again is 267 degrees, which is more than 390s, right? So we gotta think about what's going on in there.
Oh, what happened? What?
Do you know what this angle would be, Mariana? If these are both facing due north, and this is a 105, do you know what this guy has to be? 75? Yeah.
Oh, so you wouldn't take it from.
So all the way around, yes, 360.
Oh, cause I was gonna do 360 minus 66 and get that. Oh, never mind.
And then minus 75. So what's that leave?
18.
Okay, so this little angle, the plane has turned back and he's making an 18-degree angle with his original path, okay? Now, it says he stops and the airport is exactly 120 miles. Okay, this is where he took off and this is where he landed. Now, I made it look like a 90, but I don't think it's a 90. What's next below this 105?
75.
Okay, so what is this in our triangle?
Is it 87?
Yep. Now, they want to know the total flight path, or how far the plane flew. It flew here and here, so you need to find both of those and add them together. Okay?
Oh, bless you.
Sorry, thank you. Yes.
Number 2 on 9A.
Okay. Yeah, picture that's very tiny again. Did everybody get this written down, whatever they wanted off this?
65, 90.
Okay, this was, again,
That's
10.2, page 634, number 52, okay? Right, back to the worksheets.
it's right there.
Was it 2 or 3? 2? All right, let me see if I can make a better. If I stretch this out enough, we can actually write on it. The idea, Brandon, is that this is making a right angle with the ground, right? And this tower is also making a right angle with the ground over here, okay? So if we do 90 minus 21.4, we'll get this little angle in here. Is it 68.6? If this is worksheet 9A, number 2, maybe?
Wait, who's this?
Is it 68.6 or did I it is right? Okay. And then up here, this was a 90, but then the guy had to look up from there, another 18.6. So 90 plus 18.6 makes that one
108.
108.6. So now we can find this little bitty angle out here.
Bitty, bitty. 230.
2.8.
Okay. Now, I know one side of this little green triangle over here that I've badly drawn. Okay, I know this 15 down here, right? So I could find either of these two sides. What I want to do is find the height eventually, so I think it would benefit us to find that one. Does that seem okay? And then we can use the right triangle again to find the height. that another one, Mariana?
No.
No?
Can you go back to number 50?
Yes. $52 or $50?
Okay. I found the height and X and Y, but how do you use those to find the distances from the
Okay.
to the tree?
You really didn't need both X and a Y, but it's fine that you found, it asked for the height, okay?
Right.
But if you found X in the height, you really could use Pythagorean theorem, I suppose, to find this piece.
Oh.
Okay.
We can use like tangent and stuff.
Or, yeah, you could use tangent or cosine. And then once you find this one,
Same thing.
well, you could, or you could just subtract from 400, right? Because the whole thing down there's 400. So 400 minus one of them will give you the other one.
Okay. Thanks.
You bet. You guys are asking all the hard questions. Grant appreciates it when he goes to
50.
check stuff.
Oh, wait, do we already do that one?
Yeah, we talked about it.
Oh.
Yes?
Do they have an area formula that has two signs in it? I mean, I know they have the area formula 1/2, A times B times sine C. I mean,
I think it was on a worksheet, but
Because I'm just thinking, a slicker way.
would have been to find
to
the area.
and then divide by the base and then figure out the height. Is that
Yes.
what the question is?
Yes, to just find the height.
But I don't know if that's a formula they have.
There's one on one of the notes that I never use.
Yeah, it's one
'Cause
I
I
don't
don't-
use either.
Yeah,
It involves all three signs.
right. Yes, it's on there, and I kind of said to them, here's a formula, but I never use this one because,
But I was just thinking about
yes,
that.
yes, that would have been shorter, definitely. You good? Tomorrow, we will be reviewing. We will be doing worksheet 11. It is review for Wednesday's quiz. And if you have any additional questions, I can hopefully get to those quick. And I will hand out the homework check sheet tomorrow so that you can fill it out before Wednesday, okay? I have to go tomorrow. But I have subs lined up, I think, so you don't need to try to come early.
Can you go back to number 52?
I'm gonna come back anyway, so. Yes?
Said any chance to get that written down? I was wondering on 50.
Yes, yes. No more questions? Should I stop the recording at least? Okay.